So we finished till the methods of preparation of phenols.
Okay, that means you have already completed what we say chemical properties of alcohols. Yes or no?
So I'm not sure, but we did methods of preparation of alcohol, and yeah, the last thing we finished was methods of preparation of phenols.
Okay, so first you did MOP of alcohols and after this MOP of phenols, right?
Yes.
Okay. Sorry. Oh, just wait for few minutes. Aisha is joining and she has other chapters. So we will just take a common topic and then we will do some practices. Okay.
Okay, sir.
Okay. So if you have any doubt in any topics from any of these chapters, you can ask me.
Okay, sir.
Okay. Just till then you revise. Just I will wait for 2 to 3 minutes only. No, I didn't. I thought I said joined. So Rabia, let's start preparation of alcohol. Okay.
Okay, sir.
Okay. So can you give the can you see the screen?
Sir, can you repeat?
Can you see the screen?
Yes, sir, I can.
Please start. Very easy question. Basically, here it is: when vapors of secondary alcohol is passed over heated copper at 573 Kelvin, the product formed is.
Option D.
Option D it is. Have you written the reaction? So basically, see, it's very easy. Uh, you told me the right answer. Since if you have an alcohol which is secondary and you are passing it through vapor, so it will be converted. Oxidation of alcohol will take place, and you know that if primary alcohol is there, then it will convert into aldehyde. If secondary alcohol is there, then it will be oxidized to ketone, right? Very easy question. The next question, it is also from the
So I'm not sure, but I feel like it's option B.
yeah, wait a minute, I haven't given the all the options. Just make sure that you are giving the right answer. The other two option is here. Forgot to give. What did you say? What was the answer? Just make sure then answer me. Okay.
Option C.
No, you should write the reaction actually. Should I explain?
Yes, sir.
Okay, so it's very easy. You can see the compound A on treatment with sodium. If you are going to treat this with sodium, you are getting B. And with PCl5, you are getting C. Now B and C together react with each other to give what it gives? Diethyl ether, right? It is diethyl ether. That means C2H5O, C2H5O. Okay. Like C2H5O, C2H5, C2H5. Okay. Now we need to tell the examiners that what it is, this A, B, C. Now, if you are going to treat, let's say, since C2H5O is there, so I'm going to take alcohol A as C2H5OH. And if you are going to treat this with sodium, you know what will happen? This will be eliminated. H plus it will give since it is acid, and it will be O negative, Na positive. So basically, this is your A and this is your B. Now, again, if you are going to treat this with PCl5, you know the preparation of haloalkanes from alcohol. What you need to do, just replace this alcohol with one of the chlorine, so it will become C2H5 Cl. So this is your C. If you are going to treat this together, this one and this one, you know what will happen? This is positive, and here chlorine is more electronegative than carbon. So this will be negative and this will be positive. So this negative and this positive combine together, and this negative and this positive combine together. So it will be C2H5O, C2H5. So this is your diethyl ether, and the byproduct will be NaCl. So this is your A, this is your B, and this is your C. You can see C2H5, C2H5OH is A, C2H5Cl. This is, just wait a minute, it's a mistake. If you are going to treat A with sodium, you will get B. Okay, you will get B. Mhm. So A is this is your B, okay, and this is your C. Okay, it's all right. We need to tell A, B, C. So you can see this is your A, this is your B for B, and this is your C. Is that clear?
Yes, sir.
Okay, can we move to the next part?
Yes.
Just the compound A on treatment with sodium gives B. Okay, with treatment of sodium gets B. Okay, this is your B. Okay, okay. B, C, it will get this. Okay, moving to the next question. So you know how to draw the isomers, right? Primary, you need to go for primary.
Option B.
Option B is the right answer. Very good. I think this question I have already given you. Let's see. Just let me give the option as well. Here is the option that I'm going to give you. This is your option.
Option A.
Option A. Let me just check it. Which of the following reaction can be used as the for the preparation of alkyl halide? Okay, this is correct. This is also correct. This is also correct, but this is not correct because the reagent is not available. See, this is possible. This is primary and this is also primary. But here, to carry out the reaction, there is an hydride ZnCl2. So 1, 3. Okay, very good. Are you aware of this iodoform test? Yes or no? Are you aware of iodoform test?
So I think so. I'm not sure.
See, iodoform test. Basically, see, if you will study in aldehyde ketones and carboxylic acid, iodoform test is the one which will be shown by methyl ketone, and also methyl alcohol. What does this means? What does this mean? Basically, methyl ketone. You know, this is your ketone. So alongside this group, if you can see this is your ethyl and this is also your ethyl. So this will not form iodo test. But if you have something like this is your ketone and this is your methyl group. This is what? This is your methyl group. So this will show iodo ketone. Also, you can see this is your CH3 CH2OH. So alongside this, you can see methyl is there. So whenever nearer to this or directly attached to this group is methyl, then that will show iodoform test. So you just need to do what? You just need to draw all the isomers and see where OH is, how it is present. Is it nearer or directly attached to the methyl? Then it will show iodoform test. Okay. You can do
Okay,
this.
sir.
Yeah.
Option C.
Let's see where you are wrong or correct. So it's correct answer. Very good. Moving to the next question. It is a little bit the reaction type. I think you can do this because in the previous class I explained this as well.
Option D.
You told me option B. That's good. That's good. So it's very easy. This type of reaction you can see CN is will have negative, this will have negative, positive, this will have negative, this will have positive. So this will directly attach to this. So it becomes CH3 CN, right? And then again H3O positive is there. So what you are, if you are going to hydrolyze this will be converted into carboxylic acid. Again, this is carboxylic acid. And if you are going to use lithium aluminum hydride, then it will be reduced very a strong reducing agent. So it will reduce into directly alcohol. So it is ethyl alcohol. Very good. Are you able to see the new screen? Very important question.
Uh, Option A.
Option A is the wrong answer. See, you have to be careful when you are going to treat this type of reaction. What you need to do when glycerol is treated with excess HI is there. What will happen is, first of all, you are going to write the glycerol structure, CH3 and CH2, C OH, and then CHOH, and then comes your CH2OH. Okay. If you are going to treat this with excess HI, so since 3 OH is there, so I'm going to take 3 HI and all the OH will be replaced by I. So what will happen? CH2I, then comes your CHI, then comes your CH2I. Now, again, you can see that uh, iodine is larger in size, so it will be unstable on this. So what will happen? 2 iodine will be eliminated. So if you are going to eliminate this and this iodine, so what will happen? There will be double bond between these two, and it will be as it is CH2I. Now, since HI is in excess, so what you need to do, again, you are going to react this with HI. HI. Again, you are going to react this with HI. So if you are going to react this with HI, so here Markovnikov followed. Do you know what is Markovnikov? I think you are aware of this. Yes or no, Rabia?
Yes.
Okay, so in Markovnikov, this HI has two parts, negative and positive. According to Markovnikov, negative part will go along double bond to that carbon which has lesser number of hydrogen, and positive part to that carbon which has greater number of hydrogen. So what it will be? It becomes CH3, and now it becomes CHI, and there will be CH2I. Again, what will happen? Again, on two carbon there is on adjacent carbon there is two iodine, so I2 you are going to remove. If you are going to remove I2, again what will happen? Double bond will take place, double bond will be there, so it will be CH2 double bond. Again, what you are going to do? Again you are going to do the reaction with HI since it is in excess. Again the same rules will be followed. This is negative part, this is positive part, and we are going to do Markovnikov. And Markovnikov, how you are going to recognize whether it is a Markovnikov reaction? So if you are going to react HX with alkene in the absence of peroxide, or there is nothing except alkene and hydrogen halides, then that is Markovnikov, and it says that negative part will go to that carbon which has lesser number of hydrogen, and positive to that carbon which has greater number of hydrogen. So what we have now? CH3, CHI, and CH3. So this this will be the major product, and its name is basically 2-iodopropane. You can see this is also the this will also be the product, but very less stable. This is also very less stable, and you can see iodine is at symmetry position in between two carbons, so that's why it is stable, and this will be your answer. Okay.
Yes.
Please do write this reaction, very important reaction it is. Let me know when you are done with this.
Done.
Very good. Very easy question.
Option C.
Option C. Very good. So have you solved the reaction? It will be like this. If you're going to treat this with PBr3, this reaction is from haloalkanes and haloarenes. This OH will be replaced by Br. So what it will be? C2H5 Br. And again, if you are going to treat this is your X, if you are going to treat this with alcoholic KOH, then elimination reaction will take place. This is also from haloalkanes and haloarenes. So it will be C2H4. Basically, it will be CH2 double bond CH2. Elimination reaction will be there. You know what will happen? This is your CH3 and this is your CH2Br. So I'm going to write it like this. Now this will be your CH2 and H is there. So you just need to remove this and double bond will be there. And if you are going to first, you are going to react this with H2SO4. You know, this has two part, H plus and HSO4 minus, H plus and HSO4 minus. So you just need to do this. You can see it will be CH2 and it becomes basically CH2 and then, sorry, hydrogen will come here, CH3 it becomes, and then CH2 HSO4 minus HSO4. And again, you are going to treat this with alcohol. So this place will be removed. This will be removed and it will be OH. So very easy it is. No, you know, this will be in negative. This will be positive. Water has two part, H plus and OH minus. So this OH will directly go with this and it becomes ethanol. This is how you did it. Yes or no?
Yes, sir.
Just wait a minute. Okay. Let me know when you're done with this.
Option B.
Option B is the correct answer. Very good. Now, are you comfortable with the nomenclature?
Yes, sir.
Okay, I'm going to give some questions from NCRT as well. So, uh, this is what you need to write the nomenclature of the first, second, third, fourth. Please do it. Will you be able to do this? Any answer? Rabia?
Yes, so for the first one, I got 4-chloro 2,3-dimethyl pent 1-ol.
Pentane 1-ol. Pent, not only pent, because only a single bond is there. So it will be pentane.
Yes,
Okay.
sir, pentane.
For the next one,
So I'm confused in the last three.
see, basically it will be you have a bridge like this oxygen bridge functional group. Okay. So on the right hand side you have 2 carbon and on the left hand side you have 3 carbon. So you will go with the, just wait a minute, let me explain this. Yeah, you have 2 carbon on the right hand side and you have total of 3 carbon on the left hand side, right? So this will be the parent chain. I'm going to number it 1 2 3, and in this is your ether, right? You know the nomenclature of ether, it's very easy. So it will be nomenclature of ether is like alkoxyalkane. So this oxy is for the branch. This oxy is for the branch. So this is your branch. We are going to treat this as a substituent. Its name will be 2-ethoxy. Eth is for number of carbon as substituent. And how many carbon in the parent chain? 3. So prop, and they are singly bonded. So propane it will be. Is that clear
Yes, sir.
for this one? Sorry. Sorry. Just let me know. Are you done with the next one?
Sir, I'm not sure, but I'm getting 2,6-dimethyl cyclohex.
No, no, this
Uh,
is your phenol. And this is your benzene. When benzene OH is connected to benzene, then it is phenol now. You have done the numbering clear, good. 1, 2, 3, 4, 5. Just wait a minute, I did some mistake. OH is the functional group, so we are going to start from here. So it is your 2,6 dimethyl phenol. Is that clear?
yes, sir.
And for the next one, you can see this will be 1 and this will be 2. So for 1 ethoxy is there, so it will be 1 ethoxy, 2 nitro, 2 nitro cyclohexane.